Welcome, dear friends of protection, control and electrical engineering. Today I'm gonna show you how we calculate the ground fault engineering or the earth fault conditions of very complex grids. Therefore, we're going to use RelaisSim-Test, which is a software by Omicron and is usually developed for protection relay tests. But you can also calculate very precise with this software. And that's the reason why I love this tool and why I work a lot with it. So I'm not paid by Omicron making this video today. It's just because I fell in love with RelaisSim-Test. Okay, let's get started. First of all, we start the software. You can, of course, you can check if there are some updates available. Obviously, we are running on the latest version, which is always a quite good idea. And then you simply start the software. Okay, here you have a lot of stuff. You can read the manual. It's all still in German, but you know, these are the same switches, okay? Or can I even change the language? That's interesting. Can I change the language? Let's see. Here are the options. Yes. Oh, I make it in English for you. Start new. Oh. Perfect, that was fast. Okay, here you have the get started manual or the get starting guide. You have some videos. This is mainly a connection to YouTube, to the YouTube channel of Omicron, and you can learn this software. And I want to show you how I create everything from the scratch, and therefore we start this new test document. Here we have 4 options. First option is you can choose templates, which is the same if you go to this button here. One folder pops up and here you have a lot of templates which you can use, and they are very great for calculations and tests and so on. But we want to make it from the scratch, as I told you. And here you can choose own templates if you prepared some in advance. I didn't. And here you can start from line topology or from substation topology. For us it doesn't matter, we just chose line topology because what we now are doing is the process of creative destroying, because we are going to delete everything. Let's go to the power system and just delete the entire power system. We also delete this test set, and this test set here, we just chose a different one. Let's make a CMC 356, which is the biggest, the flagship, which I like much more. And then we also delete this simulation test. Okay, now we have the most available virginity of this software and we just get started. Let's dive into it. And everything or every net model always starts with in feed or a grid. First of all, you can use this line here for all the net elements. Just click it and drop it somewhere. Or you can use the right mouse button for this pie menu, which is also very handy and I like a lot. And yeah, okay, so we created our in feed, and now it's very important that we have a name for it. Let's call it substation A. Show the label, and yeah, it looks pretty good. This is our substation A, and now we also change the nominal voltage to 20 kV because our project is going to be in the medium voltage. Very important is this button here. We go to an insulated grid because we don't want a grounded network. Our aim is to calculate the ground fault conditions for insulated networks, and for this reason we opt for insulated. Here we can just type in the maximum short circuit current, which are 25 kiloamps, for instance. Oh, something went wrong. Okay, and we are done. Another thing, if you click somewhere in this empty area here, you see default options, and here it's a very good idea to start with our 20 kV and say also that everything should be insulated, okay? So this is a kind of default option that we have always to prepare in advance. Okay, substation A, and now we need just a first bus bar, and since we just entered here this 20 kV, every new grid element that we add, like this bus bar, will automatically get also this 20 kV, okay? Just rotate it a little bit and put it under the substation. Now we want to connect these two things here, but first of all we will name it. This is our 20 kV in-feed bus. Yeah, let's call it so, I don't care. And okay, that looks good. In order to connect grid elements in RelaisSim-Test, you just have to move your mouse arrow around the elements, and you will always see these little green waves. And if you have one little green wave and you keep the left mouse button pressed, then you have this connection line, and you can find another side or another point to connect it. And in this way here I see green waves again, and just let it pop and drop and everything fits perfectly. As you can see, we automatically get a circuit breaker generated, which we can switch already. And here we can also determine the initial state. So for us, this switch should be always closed. Okay, perfect. Let's enter another bus bar. Okay, so this one is a bit bigger. And now we have a big cable which is feeding our main bus bar. First of all, we name it. This is our medium voltage main bus, MVMB-A. That's the name. And we also show the name in the single line diagram. Okay, let's add a line model for our cable. And here, what I really love on this software is you can put it everywhere. It really doesn't matter. Just make sure that you take the 0% at first here and just put it to this connection point. And if you take the second point here, then the software automatically recognizes where the line should be shown. Okay, that's perfect. Let's make it little bit bigger. Okay, and here you can see it starts from 0% till 100%. And if we accidentally put it in the wrong way, we can also toggle it here with this toggle switch. Okay, so now it's very important for us that we enter all the informations for our cable. Therefore, I have here our cable data. Let's make it a bit smaller and put it here. And we also name this line. It's a N2XSY cable with 300 and with a length of, let's say, 500 meter. Okay, let's show the label. And now we can enter the nominal current. It's about 650 amps for such a line. And here we need the 0.5 kilometer. And here we can enter the line impedance. And for the line impedance, you see there are a lot of ways to enter it. You can use the K-factor, the impedance itself for the positive sequence system and for the zero sequence system. I always prefer to enter it per kilometer, and that's what I do now. So of course we have the resistance in the positive system sequence. It's 0.09, yeah, it's 90 milliohm. Then we have 0.107, then we have 0.24 and 0.42. Perfect, that's all. And you can always get this information by the cable manufacturer or by the cable vendor, or you have also a database somewhere, or you can dig it up in books and so on. So there are a lot of sources available to get this data. Okay, so we don't need mutual coupling. This is just for overhead lines, for power lines. We need to enable the capacitance. That's very important for us. And we have again the positive sequence system and the zero sequence system. Okay, here we have probably about 0.35, and here we have a bit more than the standard value. Let's say we have 0.3 microfarad per kilometer. Okay, this could be something between 2, 3 or 4 amps for each kilometer of capacitive round fault current. Okay, that's all, and now we are done with this beautiful cable model. Okay, now we have via right button the possibility to duplicate the element. Okay, I don't know what happened. I accidentally deleted I know what happened. The delete button and the duplicate element button are close together, and if you hit delete element, it is deleted. Okay, that's probably something where the makers of RelaisSim-Test should think about again. Okay, but accidents always happens, and this is not a problem. This is just part of the game, and I just reconnect it and rename it. So if I remember right, the name was medium voltage. Let's call it medium voltage bus bar A. Okay, it looks much better than the shortcut before. If you do it twice, it always gets better at the second time. Okay. Now I be very careful in duplicating this element, and I just I just make it a bit smaller. Yeah, probably like this. And we rename it. This is medium voltage bus bar. Let's call it medium voltage bus bar. It's just 1A. Okay, let's call it 1A. 1A is good. I love 1A. Okay, duplicate this element. Make it much bigger. And duplicate it again, and rename it, of course. So this is 2B, and this is 3A, 2A and 3A. So you always should take time to name all that stuff, probably because that helps a lot. So now we just need to connect all this bus bars. But what I want to show you now is sometimes you have two parallel systems for the in-feed. And in this case, I want to show you how you can make this. Okay, let's say we have here this one cable and we have another one. We have another cable system of 3 cables which are parallel to the first one. Okay, and this is pretty easy. You just duplicate this element and just connect it again to these points. And now we have two overlapping elements which are parallel. You can't see it, but you can see it if you if you just take this point here and put it to the right, now you can see what here is really going on. So we have a parallel tree, we have a node here, we have a node here, and yeah, we just hide it here, and that we don't forget it, I write it down here. We have two systems, and this will remind us that there are two cables inside, okay? So that means that the power of the capacitive or the capacitive current here also doubles. So we have the double amount of capacity, yes? So we have here 0.3 in the zero sequence systems, but we have two of them because parallel capacitance always are like adding, just using addition, okay? Okay, so now we just copy one of these cables, we just duplicate it and use it for this connection here. Let's have a look. Okay, let's make it a bit shorter. Let's say these are 100 meters, and now we can duplicate it again in order to connect our bus bars. Okay, we duplicate it again, and you can rearrange everything here. That's really handy, as you can see. This looks pretty good. Okay, perfect. Okay, we have a lot of space here. That's nice. I like this. Probably we can get here some more space and enlarge this bus bar a little bit. Okay, perfect. And now we want to have some loads in this area, some low voltage loads, and for this we going to need some transformers. Okay, let's take this two winding transformers, and the name is not so important at this moment. We have a DYN5 transformer, which translates or which transforms from 20 kV to 0.4 kV, and we have a power of 1.6 mega volt ampere. Here you can see the resulting rated currents that are calculated right now, and the short circuit voltage are 6%, and it's a 3-limb, yeah, a classical 3-limb transformer, and the grounding for the low voltage side is 0. Okay, so we have no resistance and so on in the low voltage area. It's a linear transformer. If you want, you can also tell your model the saturation effects and stuff like this, but for our purpose it doesn't matter, and for this reason we just leave it as linear transformer. Okay, all we have to do now is just to rotate it once to the right and to grab it and put it somewhere here in this area. Okay, so okay, now we want to connect this transformer to this bus bar via cable. We need a line model because we always have a lot of capacities due to these cables. It of course depends on the length of this cable. So let's take this line model again, but we can use also our model that we have again, and we don't have so much work. Okay, let's connect it to the bus bar, and we have still a yellow transformer because on this side there is no connection point. So our bus bar or potential point is still missed. So let's get another bus bar, rotate it. We need of course another voltage level for this bus bar. We are not able to change it by now, but look what happens if we connect it to this transformer. Then we are able to we don't have to do it because this software is so smart. It just did the job for us. Okay, so this is now our low voltage bus bar. Let's call it 1A. Okay, and we don't show the label. Okay, and all we just now want to add is a little load to this system. We just rotate it once right and connect it again, and now we have to put the proper voltage in it. It's 0.4K, and then let's determine the power. It's 0.8, for instance, MVA, so 800 kVE, and we have a cosinus phi of 0.85, for instance. Okay, that's all. Another great tool in this software is that we are able to group some grid elements. I show you this right now, and if you have grouped them, then you can use it every time you need it. You just put it somewhere and just duplicate it again. So now let's put here another 2 loads to every bus bar, and all we have to do now is to connect them, and for that we just take this wave, put it to the top, and RelaisSim-Tests now ask us if we want another CB line combination, if we want to add another circuit breaker, or if we just say, no, I have enough circuit breakers in my grid, just merge it, and it will merge it. We do the same for all of our, oh, this was a little bit, yeah, it was okay. It's not how it's supposed to be, but this is better again. Let's see if I can, okay, perfect. And now we can also take them all and put them a little bit to the top, and everything is smooth and clean. So we don't need this anymore. Just delete it. And now comes another magic which I really love of this software, because now you can string A everything. You just select everything and say duplicate elements. So now you take the entire crowd here, put it to the right side, and then you go to flip horizontally, and what you get is really amazing, because now we have the entire system mirrored, and this is how it often works. You have 2 independent infeeds, first maybe from substation A, and we have here substation B, and we have here this 20 kV infibus, and now we only have just to change a little bit the names from A to B, and everything is pretty perfect. You can even change it here, just double click it, it's probably a bit faster. Let's keep this in mind for the next time, Alex. Okay, that looks good. Okay, and that's all. Now we got it. And the last point I want to show you is how we can add a coupling, because sometimes probably here are some maintenance works going on in the substation A, and here is no connection. Then you want to connect all of these loads to the B side, and for that we get a coupling, and we just use our existing line element again. Let's do this probably like this. Okay, put it a little bit to this side. Okay, perfect. And we do the same with the other side. Duplicate element, connected to this point, and connected to this point. It looks quite good. Let's shift it somewhere over, and maybe like that. Okay. Here's the point. Where's the point? Ah, here's the point. Okay, we got it. Okay, and now we're done. This is our grid. This was the first part of our tutorial. Next time I'm going to show you how you can insert the current transformers, the voltage transformers, the relays, how to prepare the measurement points, and then how we are able to calculate and to make the ground fault engineering into this grid. Thank you for watching. See you soon, and bye bye.